Dear students, today we will discuss dimensional analysis. Dimensional analysis. What is dimensional analysis? It is the analysis of the relationship among different physical quantities by identifying their basic or fundamental quantities. Or it is a method used to analyze relationship between physical quantities. Dimensional analysis is a method used to analyze relationship between physical quantities by examining their dimensions and units of measurement. The dimensions of the basic quantities like length, mass, time, etc. What are its applications? So it has three applications. Number one, to check the consistency of the certain relationship. Secondly, to establish the relationship among different physical quantities. And third, conversion of units from one system into the other system. So today we will discuss first application to check the consistency of a relation dimensionally. Dimensionally means according to dimensions we can check it, but as far as the constants are there, suppose we have this driving force or viscous force is Stokes force is 6 pi neta RV. So we can check it whether this neta RV should be there or, but we cannot check that whether it should be 6 pi or 4 pi or 8 pi. This constant cannot be checked. Only the dimensionally the relationship can be checked. So we'll just discuss it, then and only then we'll understand it. So this is one of the limitation of the dimensional analysis also. Later on we will discuss it. So the relationship is first F equals to 6 pi neta RV. So here F is the force, neta is viscosity coefficient, R is radius of the drop or body, and V is the velocity with which it is falling or moving. So here we have to follow certain steps. First of all we have to take LHS equals to F. Now we can have giving dimensions. So left hand side is force. When we give the dimensions, so these questions you will be only able to do if you are knowing the dimensions of different physical quantities. So that what is the dimension of the force? Yes, LHS equals to M1 L1 T minus 2. So this is the dimension of this. Now we have RHS. What is in RHS? Yes, that is 6 pi neta RV. 6 pi neta RV. Now giving dimensions, we get RHS equals to 6 is constant, pi is constant, so they are dimensionless. So this neta is viscosity coefficient. And what is the dimension of the viscosity constant? What is the dimension formula? Yes, it is M1 L minus 1 T minus 1. Dimension formula for the radius, that is the length. So this is only L power 1. And then velocity, the dimension formula is M0 L1 T minus 1. So according to law of indices, when these are multiplied, the powers are added. That means m raised to power 1 and plus 0 remains 1. then L raised to power minus 1 plus 1 is 0, and then plus 1 is 1, and here T raised to power minus 1, and here is also T raised to power minus 1. So minus 1 becomes minus 2. So this is the RHS, that is M1 L1 T minus 2, and left hand side was M1 L1 T minus 2. So here LHS equals to RHS. Therefore, given relation is dimensionally consistent, or correct. Since LHS and RHS both equal, therefore the given relation F equals 6 pi eta RV is correct dimensionally or dimensionally consistent. एक बार फिर से देख लेंगे. We have to check this formula or this relation. So left hand side is force F. So giving dimension we get the LHS equals to M1 L1 T minus 2. This is the dimension of the force. Now LHS is 6 pi eta RV. So therefore giving dimensions of this RHS will give RHS equal to this constant dimensionless. Neta is M1 L minus 1 T minus 1. You have to remember all these formula. Then R is M0 L1 T0. That means we can write L1. And V is M0 L1 T minus 1. This is the velocity. Now according to law of indices, the powers are added when they are multiplied. So M is power 1 and plus 0. That will be M power 1. Then here it is L power minus 1 plus 1 plus 1. That becomes plus 1 only. L1. And T is power minus 1 and minus 1. That is T is power minus 2. Therefore, it is M1 L1 T minus 2. Here we see the LHS and the RHS are same. Therefore, LHS is equal to RHS, and hence the given relationship or the given relation is dimensionally consistent or correct. Let us check second relation. Kinetic energy equals to half mv square. The kinetic energy is half mv square. So here LHS equals to kinetic energy. So giving dimensions. What are the dimensions of the kinetic energy and work? They are same. Then that is yes, M1 L2 T minus 2. Force into displacement. Work done is force into displacement. So force is M1 L1 T minus 2 multiplied by 1L. That you will get M1 L2 T minus 2. Now the right hand side is half mv square. So giving dimensions again, you have to follow the same steps, and if you do it step by step, then you will not commit any mistake. Your question will become absolutely correct. So the RHS equals to the dimensions of half. It is dimension because it's constant. Then M is M1 L0 T0. Then V is M0 L1 T minus 1 whole power 2. Velocity M0 L1 T minus 1. So here you will have M1 L0 T0. According to law of indices, if they are power of power, then they are multiplied. So M raised to power 0 into 2 is 0, L into 1 into 2 is 2, and T raised to power minus 2. Now they are multiplied, so the powers have to be added. So M raised to power 1, then 0 plus 2 is 2, and 0 minus 2 is minus 2. So here again, here LHS is equal to RHS. Therefore, given relation is dimensionally correct or consistent. So since LHS and RHS are same, therefore the relation is correct. Here you can see again LHS is equal to kinetic energy Ke. Giving the dimension of kinetic energy are m1 L2 T minus 2. That is same as that of the work, and work is F into D. So you can just get it. Then RHS is equal to half mv square. The giving dimensions, we get the RHS as this is dimensionless. The mass is m1 L0 T0, and velocity is m0 L1 T minus 1 whole power 2. According to the power, they have to be multiplied. So m0 L2 T minus 2, and here it is m1 L0 T0. Now they are multiplied, so the powers are to be added. So m1 plus 0, that is m1, then L0 plus 2 is L2, and T0 minus 2 is minus 2. So this is same as that of the LHS. So LHS and RHS are equal here. Therefore, given relationship is absolutely correct or consistent. Now, third question, let us check this relation S is equal to ut plus half at square, whether it is correct or wrong. So now, first of all, same step. First of all, we have to take LHS, and this LHS is equal to S. So again, giving dimensions, we get LHS equals to, what is this S? S is the displacement, or you can say distance, that is m0 L1 T0. Now we have RHS equals to ut plus half at square. Now giving dimensions here also, we get RHS equals to, u is the velocity, that is m0 L1 T minus 1, t is time, plus half is dimensionless, a is acceleration, and what is the dimension formula for the acceleration? Velocity upon time. So this is the velocity divided by time is t minus 2. So this will be m0 L1 T minus 2, and then t square, here it will be t1 power 2. This is the time and square. So here we will get, multiplying means power added, m0 L1 T0 plus m0 L1 T minus 2, and here we have t power 2. 1 into 2 is 2. So you just multiply it, then you get m0 L1 T0 plus m0 L1 T0 again. Then this plus this, which how much? X. Now here m0 L1 T0 plus m0 L1 T0, that means both are same dimensions. So rupees, 10 rupees plus 20 rupees will be how much? 30 rupees only. So that means, according to homogeneity, these two are the like terms, same terms. X plus x is, 2x, it is algebraically, but actually it comes x. So here also, since we are not taking care of the constants, we have to take only the dimensions. So dimension, this plus this dimension will remain same. Rupees plus rupees will remain rupees. Meter plus meter will remain meter. So this is here. So you have LHS equals to RHS. Therefore, given relation is dimensionally correct or consistent. So here we can say this is S is equal to ut plus half at square. So LHS S is is S. S is the length or displacement. So LHS is equal to M0 L1 T0. RHS is UT plus half AT square. So giving dimensions, the right hand side will become U is initial velocity, but it is a velocity. So M0 L1 T minus 1, and this is the time multiplied by time, so T to the power 1. So here half is dimensionless, A is acceleration. Acceleration will be velocity upon time. So divided by this one time, you will get L1 T minus 2. So M0 L1 T minus 2, and here T square. The dimension of the T is T1 and is square. So here it is M0 L1 T0 because T minus 1 and plus 1 will become 0. Here it is M0 L1 T minus 2, and here T to power 1 power 2, that will multiply the T to power 2, and then they will be added and it comes to M0 L1 T0. Here is already M0 L1 T0. If they add them, then you will get the same because dimensionally they are homogeneous and they will add up to same. M0 L1 T0. So here the LHS and RHS are same. Therefore, the given relation is absolutely correct dimensionally. Now let us check fourth relation, L equals to mv r square. So this is the L is the angular momentum. Angular momentum. M is the mass, V is the velocity, and R is the radius on which the body is moving. So the relation for angular momentum is, dimensional formula is M1 L2 and T minus 1. This is R into P. So P is M1 L1 T minus 1 into R, that is L square. So LHS, same steps we have to follow. LHS is equal to L. Then we will find giving dimensions. What we get? LHS equals to dimensions is M1 L2 T minus 1. Now we'll have RHS, that is MV R square. So here again giving dimensions. This RHS will become, the dimension of mass will remain M1 L0 T0. The velocity is, क्या होता है velocity? Yes, M0 L1 T minus 1. M0 L1 T minus 1. And the radius, that is the length. So that is M0 L1 T0 whole power 2. So here we can have M raised to power 1. These two get multiplied. So, or you can write it similarly, same as it is. And here you get power multiplied because power of power is 2, L2 and T0. Now they are multiplied, so you have to add the powers. So then M raised to power 1, 0 plus 0, that is 1. L raised to power 0 plus 1 plus 2, that is L raised to power 3. And then T raised to power 0, minus 1 and 0, that is minus 1. So here, which is not equal to LHS, therefore here LHS is not equal to RHS, therefore given relation is inconsistent dimensionally. You can say incorrect dimensionally. एक बार फिर से देखेंगे. We have to check the relation L equals to mv r square. This L is the angular momentum, m is mass, v is velocity, and r is the radius. Taking LHS is equal to L, giving dimension. The dimension of the angular momentum are m1 L2 t minus 1. Then RHS is mv r square. So giving dimension, you get mass. The dimension of the mass is m1 L0 t0. Velocity is m0 L1 t minus 1. And radius is of course length. So m0 L1 t0 to power 2. So here it is m1 l0 t0. It is same as m0 l1 t minus 1. Here the powers are multiplied. So m0 into 2 is 0. Then 1 into 2 is l to the power 2 and t0 into 2 is 0. Now they are since multiplied, so we have to add the powers according to law of indices. So here 1 plus 0 plus 0, that is n power 1. So L is 0 plus 1 plus 2, that is 3. So L power 3. So time is 0 minus 1 and 0. So this is t minus 1. So since here it is m1 L2 t minus 1, here it is m1 L3 t minus 1, that means this is not equal to LHS. Therefore here we are getting LHS is not equal to RHS. Therefore the given relation is inconsistent dimensionally or dimensionally incorrect.